now I am going to discuss like what is reaction in combustion. Okay, as I discussed in the last session, combustion is very difficult process and very difficult to predict also. Theoretically, it is considered to be the homogeneous, but in actual practice, it is heterogeneous in nature. Okay, so let us see what the reaction takes place inside the combustion. This is octane basically. So octane is, remember here, this is C8H18, okay, plus 12.5 oxygen. That is, in the presence of oxygen, fuel will ignite. So it will produce 8 carbon dioxide plus 9 water. See, let us check out the oxygen is here, oxygen is 25, so 16 and oxygen is 9, so it is 25, okay, that is correct. Now hydrogen is 18, so hydrogen is 18 and C18, carbon is, now see, carbon is converted into either carbon monoxide or carbon dioxide and hydrogen is being considered into water. So, okay, so these are the combustions reaction inside the combustion chamber. Carbon is converted into carbon dioxide or carbon monoxide. Hydrogen is converted into water. So, this is the reaction takes place inside the combustion chamber. Okay. Now, there is ignition limits. Ignition limits. What are the limits of the ignition? It is basically air fuel ratio. Okay, so this is 15:1 stoichiometric ratio and this is 7, this is 21, 9. So this is air fuel ratio. Okay. Now see, this is too rich. This is too lean. Now, air fuel ratio 15:1, we know it is a stoichiometric ratio, that is chemically correct ratio. Okay, but it is not easy to have this ratio all the time. So either we will have less than this ratio or more than this ratio. See here, it is 7:1 or 9:1, it is 21:1 or 30:1. Now here 15:1 means air fuel, air is 15 kg, fuel is 1. Here now see, air is 7 kg and fuel is 1 kg. That is why it is called rich fuel. And this side it is going to decrease. See, air ratio is going to increase and fuel is same. So this is called lean or weak fuel. Now limits are, see, for IC engine, ignition limits are 7 to 30. That is for IC engine. Fuel can be ignited, but remember that is theoretically. In actually it is 9 to 21 air fuel ratio in actual practice. Okay, so it is not easy to get the ratio air fuel 15:1 all the time, because either we will have the lean fuel or may have the rich fuel. Okay, see 15:1 is our chemically correct, that is called stoichiometric ratio. So this side it is called rich fuel, this is called weak or lean fuel. So for IC engine, ignition limit is basically 7 to 30, but 7 to 30 for IC engine, but in actual practice 9:21. We have seen the last session also. So see, best power, maximum power can be, maximum power, okay. So that one about air fuel, suppose this is 15:1, this is 17:1 or 19:1, here it is 13:1 and it is 11. So see now, if you take maximum power, so when air fuel ratio is near about 13, this is maximum power. Okay, this is maximum power, but it is not advisable to use the air fuel ratio, that is rich fuel, all the time, because it will affect your engine efficiency and it will not give you the fuel economy also. So better to go for the fuel efficient engine, that 17, neither 15 nor 13. So better to go for this, and that will have maximum efficiency near about at the 17. Okay, so this is at the maximum fuel economy, maximum fuel economy. See, this is neither very rich nor weak fuel is there, but it will give the maximum efficiency of the engine. So that is called maximum fuel economy. So see, whenever we talk about the ignition limits, there is about the fuel ratio. Okay, so fuel ratio 9:21 for the actual practice. See, from here also we can have the fuel ignition, but if we want maximum power, so maximum power will be, maximum power will be, remember, maximum power will be near about 13:1. Okay, that is called rich fuel, but it is not advisable to use the fuel in this ratio, because this is very rich fuel and it will affect the overall running of the vehicle. So better to go for the fuel economy. So fuel economic ratio is 17:1. See here, neither 15 nor 13 also. So better to go by 17:1. This is not weak, but this is called weak fuel, but it gives the maximum fuel economy. So we cannot call it as weak fuel, though it is the ratio of 17:1. It gives the better economy fuel, or it is called minimum fuel consumption, minimum specific fuel consumption. So ignition limit means there are so many ratios. Best is 15:1 because it is chemically correct ratio, but it is not easily achievable, this ratio. So we can go, another limits are there. So fuel can be ignited in IC engine from 7 to 30, but remember this is theoretical only. Actual 9:21. If we have the maximum power, so maximum power will be achieved when the fuel is little bit rich. So 13:1, see here, if you have to go to left side, this is chemically correct, no? 15:1. So this side, it is called rich fuel, this is called weak fuel. So 13:1 is the rich fuel maximum power, and if you want the minimum specific fuel consumption, that is called fuel economy, we have to go a little bit right side to the specific, that is stoichiometric ratio, chemically correct ratio. So it is this side. So at 17:1, it gives the best performance of the engine, that is fuel economy, and it will consume minimum fuel consumption and gives the better output. That way it is always advisable to run the engine at this ratio, that is near about 16, 17 or 18, not 13 or 14, because it consumes lot of fuel. Okay, so these were the about the ignition limits and combustion stages in IC engine I will discuss in next class. Thank you.